Jeez. Ugh.
Or last night, I don't know, but this morning was the news.
Okay, everybody's looks like our live online people are coming through there. Our in-person people are here. How's everybody doing? Let me go ahead and save this. Close this out. Do that. Close this. There we go. Which one are we using here? We're using Blender. There we go. Ba, 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 ba. Give me a thumbs up there that you can hear me in the live stream and that this is actually going out over the internet using our OBS. We got everything happening here. Okay, first order of business. Fabio, our fabulous GCC Digital Media Arts tutor is here. And so he's going to introduce himself and talk about tutoring. Right, so allow me to say one thing here. Right, some students occasionally think that like, why do I need tutoring? That's not what we're doing here, right? Fabio's here to sort of any sort of problem that you have. He's someone who we have allocated time, effort, and energy for him to help with individual personal problems, right? Like, as I said, I teach 3 classes. There's a lot of balls in the air. I don't always have the time to also help every student with every personal issue with your technology and or home machine, which is why the department and institution have allocated the resources for people like Fabio, and specifically Fabio in this case, to be available to you. So not every subject, and I'm sure you're aware, not every class has someone else whose purpose and job it is to assist you in your progress in that class. And Fabio is that person for our department, not only for the classes I teach, but for all the other digital media arts classes. So without further ado, Fabio. Put your hands together.
Hello, everyone. My name is Fabio Bruzzese. I am your tutor for the animation and the digital media arts. So if you guys are struggling with something, don't hesitate to contact me. I tutor online. It's to be announced if I'm gonna be in person too. I'm gonna discuss that with Casey a couple of times. Maybe we're gonna be in person, but most of the time it's gonna be online. So for a little bit of the tutoring, it's free, guys. Use it. If you are struggling, it's the resources is there for everybody. So please,
even if you're not struggling and you just need a little bit of help,
yeah, I'm here. So we're gonna announce what day we're gonna be tutoring. Normally, last semester I tutor Mondays and Tuesdays, but it's something like if you need me, I'm very flexible. If you need me off hours or like off the my office hours, just text me and say, hey, I need help, and I will do my best to schedule, to fit my schedule to your necessity. Okay. I with being with all this being said, I think I wish you all a successful semester. And again, I'm extra resource for you guys. If you're struggling, I don't know how to render. I don't know how to scale. Simple things sometimes catches you in a project, and you are struggling with that. If you're even like very little things, just give me a text. I will be available every week. So make sure that you guys are thriving through the course. All right. I think that's it.
Okay. Thank you, Fabio.
Thank you. All right, I'm gonna take off. Bye.
Okay. What was the other thing I was just thinking of? I forget. Okay. Great. Okay, everybody got their notebooks out? Let's do some more introduction to Blender. Our assignment coming up here. Let's see. Can I see my stuff over here? I can see this here. So what we're going to work on today, just to be clear with scheduling, right? So, first of all, syllabus acknowledgement quiz. You all have taken it, yes? Please. If not, do that ASAP. B, the technology orientation, that is due tomorrow night. That's the one where you get logged on to all of the things. You get signed up for all of the accounts and you make your introductory video, right? That's our big goals there with that one. Those of you who plan on borrowing a computer from the school have submitted the form. Yes. If you're planning to borrow, how many of you are planning on borrowing a laptop from GCC? Anybody in person? You guys all have good machines? Good. Let's see online. Maybe the online's a little bit delayed. Hopefully they have also submitted it. What we talked about on Monday after all of the orientation stuff and what we're going to talk about today, this will be part of our weekly project, and the weekly projects are due Tuesday night at 8 p.m. right? And that project will then be discussed the following Wednesday in class, right? We look at part of everybody's weekly project. There's multiple things. In this class, it usually takes the form of, some sort of blend file, right? Show me what you've been working on. And then there's also a presentation video where you take somewhere between 3 to 4 minutes to talk about what it is that you did, right? At the beginning here, there may not be a whole lot to say, right? It'd be very introductory. It's not going to be there'll be less creative decision making here at the beginning because we're just getting rolling, okay? But occasionally in the presentation video, I will give you direct questions to answer, which is kind of like a quiz. Like, explain UV unwrapping will be something that you will definitely be asked later during the semester, right? And that'll be my chance to see you explain that, to see whether or not you understand what exactly that is, okay? But the video is a combination of those things. It's, explaining your artistic decisions and showing us what you did, then also presenting your work. What else do you turn in? Maybe sometimes a render, and that can take the form of either a still or a movie, right? So what you turn in every Tuesday night is some combination thereof of those things, right? So multiple things. Those details are detailed in here, here, right? So up here, you'll see links to both of the lectures. You also know where to find those, right? Everyone has bookmarked my channel at this point. Yes? If you haven't, it's also right here. That has everything available. Here, in our week 1, any sort of resources, right? So occasionally this may be something I'm asking you to read or just links to other resources that we may have referenced during the week. This is just some of the add-ons. Then there's the specific project objective. What is it that we're doing here? Some sort of very light step-by-step of what we're doing. Again, this and this are usually patently obvious because you've already heard me talk about both of them for 5 hours at this point, right? So there's, it's not like I lecture about something for 5 hours then ask you to do something else, right? It's whatever we worked on. So this does happen in the case where like perhaps there's something here that doesn't make any sense because I didn't talk about it. If there's ever conflict there or you're confused, go with whatever I actually said that week, right? I try to keep these things aligned, but they do occasionally drift, right? So the course competencies, these are the actual course competencies that are being satisfied or at least explored in that particular assignment. And then this is usually what the end part looks like. The deliverable, what do you actually have to deliver in order to satisfy this assignment? And so most of the time, most of the stuff goes here, right? In Canvas, the stuff you're actually turning in for the project. And so this week it's your presentation video, and then we'll talk about your chaos scene and your order scene. So you have 2 blend files to turn in this week. And then almost always there's some sort of lightweight, easy version of the assignment to post to Discord so that everybody, including the online people, can see everybody else's work, right? And everybody can be like, oh, that's super cool. How did you do this? What's going on here? Fire emoji, 100%. Yeah, totally sick, bro. Whatever it is, right? That's what Discord is for, so that we can all see everything that's going on there with everything that everyone else is doing. And so in this case, rather than all of us posting our blend files to Discord, which is not great because then you need to download and also open those blend files, I have you posting a screenshot of that blend file to Discord. If you know how to render from Blender, I don't think we'll get to that today, but if you do, you can post a render. If not, we'll also look at just screenshotting the viewport, which is fine. So for this week. Okay, does this layout make sense, right? And then week after week after week, we'll see, this part is totally consistent. This, and that's how everything is structured. Those of you who have taken my classes before, this is not new news. This is how I did it before and mostly how it's being done now. Any questions about this format here? Does that make sense? Right? So again, this is all designed to be a thorough explanation of that week's project in conjunction with what we already talked about for 5 hours, right? So again, if there's anything that's a blank here or you're having trouble connecting the dots based on something I said or the language of this, when there's anything in conflict, go with what you think I clearly communicated in class versus something that seems weird in the assignment. And if it's, really bizarre, then say something on Discord and I'll try to sort it out and make sure, try to bring things into alignment at that point. Okay, cool. Makes sense? Okay, great. The other resources that I'll link to here in our resources section is that the lecture search is operational. So I have a search site here for all of the lectures. So for instance, there you go. What is this searching? This is searching all of the timestamps in my recorded, broadcasted class. So for instance, you're like, oh, you said something about transform. And then 185, you click on it, it takes you directly to that timestamp in YouTube, right? There. So by all means, learn from all resources, right? But one maybe not so great habit that I see students come in is like every time they have a question, they jam it into YouTube. And is there a lot of great information on YouTube? Yes. Like, do I learn a ton from different people speaking? Yes. But I've done like a ton of work curating who I'm paying attention to, finding relevant and reputable resources, all of this kind of thing. That is not the kind of work that the YouTube algorithm is doing to give you search results, right? They're playing a different game where the more popular stuff is what gets forwarded to the top. Sometimes that information is really good. Other times it is not so great. Okay. So that's part of what ideally you should be learning in school is the ability to classify and rank research sources, right? That if you take nothing else away from your time in college, that would be close to the very top of the list, being able to evaluate information that you are bringing in. So this, I think, closes a really good gap. You can configure it here. So I keep all of the classes on here. If you just want to search your class, just get rid of those and then run it again, and it'll only show you results from your class. However, those of you who've taken my other classes can attest that like there's a lot of overlap here. It's not like 3D modeling is a completely, totally different knowledge base than cinematography and directing for animation, right? It's a lot of the same tools. We're using a lot of the same stuff. Depending, especially towards the middle and end of the semester, when people are working on wildly different projects, you may want to fill in some of the gaps, in which case it may be in your best interest to also look and see even though you haven't taken AVC 200 perhaps, maybe you see what I said about sprites in AVC 200. I haven't said anything about sprites yet, apparently. Or what are the transforms like in Unity? You have to spell transforms right. There you go. Or transform. There you go. And so now here I am talking about that, and here I am talking about that in Unity versus AVC 200. So how new is the information here? I usually run the update on this on Thursdays, right? So yeah, that way, because this whole system is dependent on the automatic YouTube closed captioning, and then I do a bunch of stuff to pull down the closed captions and index them and some other stuff. And that is not automatic. It needs me to say like do the thing. So the new information is usually there on Thursday. The video, the actual lecture itself, is there the moment we're done with class, right? It's there, it's happening right now. Like you could tune in, you could pull it up and see me slightly delayed on your screen right now if you want. But the search engine, when all of that information gets entered into the search engine, that happens on Thursday. If I'm really busy, it might happen on Friday. Okay, so keep that in mind, right? The search engine, I think this is new as of last semester. People seem to think it was super useful. Yes, people who took my classes previously? Yes. Yeah. But, yeah, it's getting there. So this, I'll make sure that the link to this page is on the resource sections of the projects going forward, right? So you can look at the other classes from this semester, and then if you really want to get crazy if you want to look at classes from previous semesters, you can. My classes always change, right? I'm an improviser. I'm just making this up as I go. So, like, we did pretty much the same stuff last year, but it was definitely different. So, if you look at previous semesters, you need to once again evaluate the information, right? Am I saying something about Blender as a program, or am I saying something about that semester's project? If I'm talking about that semester's project and it's a different semester, like, that was in the past, right? Whatever I told you about this year's project, because I do change the projects all the time, whatever I said now is what you should pay attention to there. But there is a lot of information there in terms of just, there's a lot of relative stuff there. But again, it was older versions of Blender and older versions of the class. Just keep that in mind. It is a historical reference, not a contemporary definition of what the class is. But the default is just to look at this semester. So, So that's all there. I had it run the algorithm yesterday. So Monday's talk is there. And I think, is this there? Yeah. And so then if you click on this goes to a list of all of the timestamps. So this is how, when you search, this is what is being returned in the search results. This is the closest available timestamp. Okay. So the lecture is being divided up into sections, right? I loosely speaking sections, except when I go on tangents, but the tangent itself is a separate section. And then that's what comes back, right? So it's looking for the specific word that you search for within that timestamp. And then this is more like a chapter index of the different timestamps from that week's lecture. And then some summaries of that information. So this is also useful. There's nothing. Okay, I have to fix that. This goes to the previous semester's week 2, and that's probably not great. I'll address that. But later, as that goes on, that'll be there. So again, that is here. And then, searching whatever you need here. Sphere. How about axis? Yeah. If you're using it and you come across something that is obviously, what was the big one? What was I saying? Oh, yeah. Later, when we talk about UV unwrapping, right? It's the letters, UV unwrapping. The closed captioning would constantly think I'm saying groovy unwrapping. And yeah, like at first, but now the closed captioning, the transcript correction pass I have in there now knows that I never say the word groovy, right? So now in the transcript, for what I'm telling you, right now, even though I'm saying groovy, it should get corrected to UV, so that it always has UV instead of groovy there. So there's some things like that where, obviously automatic transcription is just inherently difficult. And so I tried to skew it towards our obvious subject matter there. Yeah, Amy says that's been very useful. Yeah, I think it's this should be very useful. However, let me say this. Like, when I showed this to my father, he immediately said, like, wow, that's really impressive. No one ever needs to take notes again. And I was like, you have learned the wrong lesson from what I put this together here. I encourage you to also take handwritten notes and use this as a supplement to that, rather than using it as a complete replacement for handwritten note taking, right? You heard me talk about this on Monday. There's no substitute for handwriting notes. So cool. Any questions about that stuff? Okay, great. Let's get back to actually doing some things. I need to make a cube. Kyle, what's the shortcut for making a cube? Okay, very good. So that's a heads up to everyone else. You may be called on at any time, provided I can remember your name at the moment and looked up at that time, right? So Shift A is our add menu for adding things to the screen. Great. So we've got our cube here. And now some new shortcuts that I did in the previous class is that when you make something new, it puts it at the location, by default, it puts it at the location of this. What is this thing? This is the Blender 3D cursor, right? And so this is the mental model here is like you're working with a word processor, right? When you type stuff on the keyboard, the word processor inserts it at the location of the cursor. This is the 3D equivalent of that. I don't love this. So you won't hear me talk about it much after this. Not a lot of other programs have a similar construct, and most of the Blender tools can be used in a way that leverages the cursor. I just don't personally find it all that useful, so keep that in mind. You'll see other Blender tutorials where people use it a lot. I just don't think it's just not part of my workflow. It never really clicked with me mentally, and I don't really find it all that advantageous. But that's what that thing is. And the reason our cube wasn't, we just Shift A and added a cube. And the reason our cube is not in the middle of the world is because of this. The cursor is somewhere else, and it put it wherever the cursor is. So a shortcut here, or more shortcuts to know, is that occasionally we need to reset the transform. And that is simply Alt plus our usual transform keys. And so that's Alt G, Alt R, and Alt S. This resets those transform properties. So if I grab this cube and Alt G, boom, it puts it back in the middle of the world. The middle of the world, something else to write down for your vocabulary here, is the origin, right? Origin is going to be 0, 0, 0, 0x, 0y, 0z. And so conversely, here it's been skewed and scaled. And now if I Alt S, puts it back at 1, 1, 1. If I Alt R, it zeroes out the rotation. So you can see the results of this here, right? Let's do that again. Some random amount of scaling, or rotation, some random amount of scaling. So Alt R, Alt R, trying to look at the keyboard, and there we go. It needs to be selected for that to work. And then here, Alt S puts it back at 1, 1, 1. So 0, 0, 0. This week we'll build some stuff out of all of these things. So let's learn that word. These right here, these are primitives. So these shapes right here are 3D primitives, just fundamental building block shapes. Does that mean everything in 3D needs to be built directly from these primitives? No, but they're really useful as starting points for a lot of stuff, right? And so it's important to realize that primitives can be three-dimensional and they can also be two-dimensional. It's worth noting that this phrase, primitive, mostly refers to the idea that this is like a fundamental, sort of like atomic building block of some sort of structure. In this case, we're talking about three-dimensional shapes. So these are three-dimensional primitives. And if you go to curve, right, you could see, we have a circle, which is a two-dimensional primitive, right? So our equivalents here, a square is a two-dimensional primitive. A cube is a three-dimensional primitive, right? A circle is a 2D primitive. A sphere is a 3D primitive. You get the idea. Now, let's look at this. First, let me point out something over here. By default, Blender is metric. So the essentially 1 meter is like the fundamental building block. But I showed you this on Monday, right? Where I typed in inches and it converted it to meters. That was this class? Yeah. So we're going to leave it there for now. So it's in meters, and then this is degrees of rotation. So if you rotate the whole way around, it's 360 degrees. This is the rotation order, and when we're in degrees, it says Euler, so that's good. We'll just leave it at that for now with this. The main thing I want to say here is that, this is in meters, this is in degrees, and then down here, so the location is in meters. However, this right here, notice there is no M under scale. This is critical. This is not in meters. This is relative scale. Okay? So 1, what does that even mean? 1 what? 1 to 1. 1 represents the standard scale of said object. Okay? If you're making a chair, you want your chair to be the 111 would be the regular size of the chair. Having these numbers be relative makes scaling objects relative to each other very easy, right? We have a chair. How big is the chair? It's 1. How do I make a chair that's twice as big? You make a chair and then you set it to 2. That gives you a chair that's twice as big as the standard chair, okay? So these are relative, and it's important to realize that as you start to manipulate objects more, Blender, maybe more than other programs, really wants the scale on objects to be 1, 1, 1. Okay? It wants you to what's referred to as apply scale. There's a whole bunch of issues here as we move forward where if the scale is not 1, 1, 1, other operations will be performed in a way that is, confusing and or infuriating, depending on what it is you're trying to do. Okay, so allow me to demonstrate, show you exactly what I mean here. Okay, so this is just the vanilla default cube, right? Okay, so I'm going to Shift D this thing to make a duplicate. And now over here, I don't want a cube. I want to make something that's taller, like a column. And so I'll do something like this. There we go. And now that's good. Okay, but I've got a column, and now I want to put it back over here. And so if I reset this and I reset the scale, because notice the scale of this column now is 1, 1, 4. And if I were to Alt S this, it goes back to cube, not this shape, but I'm making a column. I want this to now be not a cube, but a column. And so what do I need to do? I need to, after manipulating it, I need to apply scale. So watch what happens when this is the shortcut for this is Control A, and then we'll just start with this one, scale. And now, when I click that, absolutely nothing happens here. It looks exactly the same. But look at the scale. Now, this configuration, this appearance, is now the default for this object. So if I were to reset the scale on this, right, no matter what I do, Alt S, it goes back to that, not the cube. Let me show you. At first, this may seem like unnecessarily overcomplicated nonsense, and it definitely has that layer to it. But let me show you another example here, because this just, let's just all write it down right now. Like, you have a problem in Blender. It turns out most of my job, right, like 75% of answering student questions is, did you apply scale? And they're like, oh, no. And then that solved their problem, right? So that's literally most of the issues. So let's all sort of internalize it so that you can solve your own problems there, where if you're running into something in Blender, the first thing you should consider is like, wait, is the scale of this object 111? If not, other things may perform strangely. For instance, I'm going to take this one, move it over, and do this to it, okay? And then we're going to use a modifier, which is this tab right here. Some of you will be familiar with this. Modifiers go onto meshes and they transform them in some way. And so we're going to use the bevel modifier, which is going to simply just round the edges of the cube, okay? This will be one we use often for many purposes, okay? The bevel modifier. And I will take this one. So this is let's label things here. And so this one is the cube, and we'll say applied scale. And then this top one is just the cube with unapplied scale that has a skewed scale, okay? We will apply the bevel modifier to both. So here's the applied scale one. I'll go to modifier and I'll search for bevel and I'll apply that. And if we look at it over here, we will see this is the bevel. By default, the bevel is not curved, it is flat. And you can sort of experiment here. This is how big the bevel is. And then the segments is rounding it. And so how round do we want it? And so usually that's like 3, maybe 2 or 4 are good numbers here, like depending on how big the bevel is. You see how we can see the individual what's. Aiden, what are each of these things I'm pointing at? It's a what? I'm pointing at the middle, in between the points. Faces, that's the face, right? When we can see the faces, the phenomenon of seeing the faces is called faceting, okay? And this looks kind of retro, right? It looks like a PS2 game or something, right? This is another instance of the reason those games looked like that is because things had to be faceted. Making a really smooth surface was not on the table at the time. Is it okay to make low poly stuff that looks retro in Blender? Yes. Is that what we're trying to learn right now? No. And so we can get around the faceting by right click and say shade smooth. And so now that we get a clearer representation of the bevel. It's a smooth beveled thing. Okay. Now we beveled that. Great. Congratulations. Let's come over to the other cube where we didn't apply scale. And I will apply the bevel modifier and watch what happens. Boom. Let's inspect a little bit better. Let's a little bit closer here. What's going on? Does this look like the other cube? Ro, what do you think?
No, it doesn't look quite right.
What's not right?
Like the bevel, the angle is off.
Yeah, it's skewed, right? And it's skewed in this vertical direction. That is the direction with a larger scale number, right? And so every time you run a modifier, most of the modifiers, you can think of these scale numbers as multipliers, right? And so it is multiplying the z directional bevel by that number, hence giving you this unequal bevel, which in most instances is not what we're after. We want the bevel to be applied equally across the surface of the object, right? Because any number times 1 is what? No. Yes, it's the number, right? 7 times 1 is 7. 7,000 times 1 is 7,000, right? So the 1 there is very important. That's why this apply scale is super important. But the good news is that you can save yourself later, right? So here I started my column and then I'm like, oh, I want to bevel this column. So I put the bevel modifier on there and then it looks all weird. And I was like, don't worry. Even with the bevel modifier on there, I can Control A scale and boom, I've applied scale and the modifier calculations have recalculated and now they look fine. They look good. They look equally proportional across the entire object because I applied scale. So big capital letters in your notes, a big, something's wrong. How do I fix it? Control A and then select scale. You don't, this is, Control A scale. This is apply scale. There's similar concepts for position and rotation, but not far and away the scaling issue, especially when you're working with primitives, is the more pertinent and obvious one. Hopefully YouTube picks this as the thumbnail for this video. I don't go back and edit the thumbnails. Maybe I should. I just applied scale and you won't believe what happens next. And then Photoshop my face in there. I was like, yeah. Okay, so the bevel modifier rounds out edges like this. If we look at our sphere, what do you think? Is the bevel modifier going to do a lot for this sphere? Usually no. The bevel modifier is taking things that are really angular and then rounding the edge. So we'll definitely get something to happen here. But there's a couple things to consider here. So one is that, let's come back to this, our friend cube over here. And so amount, I think, is pretty clear. Like this is an actual distance of how much is being beveled, and there are segments means that we're rounding. And what I would write down in my notes is, bevel, these segments. I would say the values that would be on the table for right now would either be 1, 2, or 4. 1 if you want that really blocky look. The 2 and 4 if you want it to be rounded out. The reason we want to avoid 3 is that if we use an even number, we always have a perfect center point edge that we can use when we're modeling features later. If you use an odd number, there's no edge that falls directly in the center of the bevel, and that is usually less desirable. This is an important concept in 3D modeling that will come up again. When we make circular stuff, we'll have to decide how many subdivisions to have for the circle. If you choose an even number, like 8, then it becomes very easy to do some subdivisions on your circle. You can easily divide the circle in half. You can easily divide the circle into fourths, right? It's not a hard and fast rule, right? There are some instances, say I'm making a 5-legged starfish. Okay, well, in that case, starting off with 5 subdivisions makes a lot of sense, right? So the just gotta fix the screen. But if you don't know what you're doing, and you're just sort of like, exploring some ideas in your modeling, keeping an even number just makes dividing it into parts a little bit easier. So that principle can be applied here for the bevel as well. Okay, good. As we transition to spheres here, this gives me the opportunity to transition to the next thing I wanted to talk about, is that we have 2 spheres. So in Blender, this one is called the UV sphere, and then this one is an icosphere. What is different here? They're both spherical, but they have different topology. This is a vocab word to memorize. So topology is going to be the arrangement of geometry along the surface of the shape or object. So this is most easy to demonstrate in with the sphere here at the beginning, where these are both spherical objects, but they have different topology. Now, that's super visually obvious when we can see the faces. Help me out with your name again. Ken. Yes? Am I right? Nailed it. Ken, what is it called when we can see the faces? Faceting, right. If it takes a while, I do the thing where we play Wheel of Fortune, right? Or by putting the letters up on the screen one at a time. Faceting, right? Let's turn off the faceting. Trenton, how do we turn off the faceting? We have to set what smooth? Shade smooth, right? And that's a right click. So I select, right click, shade smooth, select, right click, shade smooth. Okay, well now they look more similar, especially in this part and in this part, right? You can tell they're still different here along the, what is this called? This is the silhouette. I think I got that. Is that right? No. What is it? That one? There we go. All right. I didn't nail it, but you know, it was fairly close the first time. It's French. Yeah, the silhouette of the object. You hear me talk about this often, right? Where even though you turned on shade smooth, you can see the polygonal nature of the object in the silhouette, right? And so here, a really good example of two objects with different topologies that are almost the same shape. Let's make it a closer call. And this will allow us to examine something else. So Shift A, UV sphere, and then I'm going to Shift A, icosphere. Look down here. So this menu in the lower left, okay, so this is important. This is your primitive configuration menu. This allows you to change the topology settings of a primitive. However, it disappears after clicking on anything. So you get one shot. You can Control Z back to it, but you get one shot to change the initial settings of the primitive. This may seem unnecessarily irritating at first, and there's different strategies about this later on, but I can come over here to the icosphere now, and under subdivisions, turn this up so that it's still an icosphere, it just has more subdivisions. So I turned it up to 5. And so now both of these are kind of on top of each other. Let me move them. There we go. And so now we can see that, especially when I turn on shade smooth, it's hard to tell which one is which, right? Now they both have relatively equally smooth silhouettes, but still different topologies. If I go to wireframe shading, it's patently obvious what's going on here, right? So this is a really important concept to understand. In 3D modeling, what are we doing? Like I said on Monday, the whole class is essentially arranging points, edges, and faces. That's it, right? That's all we're doing. But there's the arrangement of these atomic elements really matters. There's this relationship between the location of those atomic elements and then the actual surface that you're trying to represent. In this case, in both cases here, it's this sphere, but we've arranged the points, edges, and faces in a different configuration on both spheres. So they can be different. Which one is better? Why do I have two options here? And the answer to that question is it depends, right, on what you're trying to model. Am I trying to model the golf ball structure, golf ball center? Dial it in. The golf ball structure at Epcot Center in Disney World? Then the icosphere is probably going to be a much better starting point for that. Am I trying to model some sort of thing that's in a globe configuration? Then the UV sphere is a much better decision as a starting point, right? So for instance, just as a basic manipulation, let's say I want to grab this and let's see, Finch, how do I go into, I want to move some of these points, edges, and faces. I need to go into what mode? Edit mode. What's the shortcut for that? Tab. I need to tab into edit mode. Okay, and so this is going to be a club that my character will smash things with eventually. And so here, I'm going to grab the top of this and then press E, which we don't need to worry about right now, and extrude it out like this. And you see that that was easy peasy with this configuration, with this topology. If I come over here, let's tab back out, select this one, tab in, and grab some faces here along the top, and then try to get this, let's deselect those, and actually I'm going to need to, am I making my point here, right? Like it's really much, like there's no good answer here in order to get a very clean handle coming out of the top of this object. Because over here, the shape I wanted to make was really represented well by this topology, right? Whereas this one, not really great for this club-like configuration. But if I wanted to create like a spike ball where spikes were coming out in all directions, if I and click, you don't need to follow this part. There you go. This is more subdivisions than I was thinking it would need. There we go, like this. And then did that. Then did this. You don't need to follow this part. Extrude. There we go. And that. There we go. Boom. And so now I have this shape would be next to impossible to make with this topology, and vice versa, or in whatever, however you want to say that. Does that make sense? So this leads us to one of our, I would say, ubiquitous 3D modeling pieces of guidance. Because right now, the topology is a matter of like, did I select UV sphere or did I select icosphere? Later, the topology will be a series of decisions of you being like, how do I lay out the points, edges, and faces across the surface of this thing? You'll be doing it in a much more directly bespoke way, right? And you want the topology to follow the shape. It's in instances where the topology runs against the shape that 3D modeling becomes the most challenging, where things are more difficult. If your topology follows the shape, then manipulating said object becomes easy, right? And so knowing what you want to do, knowing the shape that you want to get to is important, right? Do I want to make this crazy extruded shape, or do I need to make this club, handle and club kind of thing, right? That's why. So you another piece of advice here: if you select multiple objects, I'm going to delete the camera for right now because it's in the way. If I select two objects as the same, and I can go into edit mode on both objects at the same time. There you go. And so now I can select faces over here, and I can select faces over there at the same time, even though they're still separate objects. So That's all there. So that's in big letters in your notes. You want the topology to follow the shape. If you just use that as a guiding principle for the first, certainly the first couple months here, you'll probably be fine, right? Which makes sense, right? You see the lines here. The lines are following the shape of the object. But they're also doing that over here as well, right? It just makes it much easier to follow the shape of what's going on. Okay, let's get rid of those. Now, yeah, a little bit more about the primitive menu. So if I come over here to Torus, this menu down here in the lower left, again, if you're not seeing this, by default, it's all folded up down there. I'm going to turn on my screencast keys. There we go. So what is this? This is essentially the formula for a torus, right? So those of you who've done the Blender donut tutorial almost certainly started with a torus, right? Again, that's that principle we were just talking about. You didn't start with a sphere because the topology there doesn't follow the shape of a donut. The shape of a torus has everything laid out in a way that's much more donut-like in shape. And so over here, this allows you to alter, one time allows you to alter the parameters. These parameters for the formula of a torus are not the same as the ones for other shapes, right? So for the torus, we have the major radius and minor radius, which one is this, and the other one is the one that goes around. And then we have the number of segments. So for instance, I can do this or this, right? But then if I were to make a Shift A UV sphere, notice these are totally different parameters. The biggest one being the radius, right? How big is this thing? And then how many subdivisions does it have in this direction or in that direction? So if you dial these very, very low, you can see we could take a UV sphere and use that as a good starting point perhaps for more like, I don't know, like gem-like kind of shapes perhaps if we dialed this down. But I clicked away and you see that those parameters are gone. Why is it doing that? That's really irritating. I still want to do this. It's just the way the program is designed for this part of it. Essentially, once you click away, you are converting from something that is procedural to something that is polygonal. So this is a really important concept to start to grasp. So here we go. One side of this equation is procedural. This is an object that is constructed by or according to instructions. The fancy word for instructions, algorithm. What is the advantage here? Is that you can change you can make what we're calling high-level adjustments. The opposite here is editable, an editable object. Synonymous with that here is going to be polygonal, meaning made of polygons or faces. This is the object with just made of raw points, edges, and faces. The advantage here is that it is totally editable. You can move each and every point, edge, and face. Which is, at first, it would be completely reasonable to be like, well, that sounds better. I want to be able to make sure my things are totally adjustable, right? I want to be able to go in and individually tweak a thing. That's fine when you're thinking about a cube, right? Because how many points does a cube have? 8, right? But what if you made something with 400,000 points and you want to make large scale changes to it, right? Then this idea that you're going to go in and manipulate individual points is crazy. It's way too dense to manipulate something on that level. So when the instant that you make a new primitive and you have that menu in the lower left-hand corner, it is in the top mode. It is in procedural mode. You can adjust the formula for the torus. As soon as you click away, it becomes editable geometry, and you can adjust individual points, edges, and faces on the torus. So, we've clicked away on this, and now I can go into edit mode and, extrude individual parts of it and manipulate it, right? Because it's in raw mode. Down here, these are just the controls for the actual tool at this point. We have this in place, and it is, why can I not edit it with the torus formula? Because it's no longer a torus. I've changed said shape, right? It's now just this raw mesh that's sitting here and is able to be edited like this. So this procedural versus editable continuum, it's not really a continuum. Let's go ahead and say it's just sort of a switch. Things usually go in this direction. You can use a formula to make a starting point and then convert it into the editable format in order to sculpt it into what you need. Later, when we use the actual sculpting tools, that's very much what's happening. But here, conceptually, to form it into whatever you would want there.
Can you give examples of procedural and editable?
Yeah. I mean, this was one, right? So let me do it again with the torus, right? And so Shift A, torus. Okay, right now the torus is procedural. An algorithm that's taking these inputs is generating this torus. And so if I adjust the radius or the other radius or the number of subdivisions here or here, it adjusts the torus. Now I click away. We have traveled on that switch. We've flipped the switch. Now, if I go into edit mode, it is editable. And so I can move the individual things. I can grab the individual points. And, now I can change its shape, but I no longer have access to the original starting point. It is a one-way trip, right? I mean, you can Control Z back to that, or you could just start over at this point. But that's an example, one example. Let me give you another one that isn't necessarily polygons, but rather objects, right? And so one thing that we did on Monday, I'm going to zero this out, was that we created a perfect, cube of cubes, right? By one of the easiest ways would to turn on the snapping, hit Shift D, and then start moving these cubes around so that they are in this grid-like pattern. Here, the procedural and editable is not going to be on the level of polygons and faces. It's going to be on the level of objects. So this is a editable array of cubes. I'm going to go Shift A and make another cube. And instead of editing the geometry, I'm going to use a modifier to do something procedural. And so I'm going to go over here, and instead of the bevel, I'm going to grab the array, A-R-R-A-Y, not the array legacy, the one that says array. And so here, what's this? This is using instructions to create multiple cubes, right? So a reasonable line of thinking here is like, what the hell, Casey? Why didn't you show us this on Monday? Because I could have done the whole thing with one object and an array rather than moving all those cubes around. And that was just the beginning of me withholding information and lying to you in order to facilitate your learning. So, there you go. So we have an array, and we could get to a cube by making arrays of arrays. So you can have multiple, this one, instead of offsetting on the X, I'll offset the second array on the Z. And so now this is the number of objects. I have a single cube here with two arrays on it that's making this grid. And so this is the length of the grid in one direction, and this is the length of the grid in the other direction, right? So in the array here, how many, and then this is the offset in terms of location. If I start to offset on Z, now we have like a stair step sort of situation here, right? Because every time this row gets copied, it gets moved on the Y and the Z, because this Y value and the Z value are changing. Whereas up here, it's just the X value. So this sort of spaces it out in that direction, and this grows it in that direction, this grows it in that direction. And, okay, word of warning here. Did I do the Spider-Man thing in this class on Monday? No. Okay, so there's a lot of cubes, right? So I managed to work it into all three classes today with great power. What's the rest of the Spider-Man quote? Comes great responsibility. Right. The array modifier is your spider powers here, right? What are you going to do? Are you going to use the array modifier to try and fight a wrestler and make money while Uncle Ben gets shot in the street? Or are you going to use the array modifier to save the citizens of New York? Which one is it? Which one is it? Right? So the responsibility here, hopefully no one dies as a result of our use of the array modifier here. I think we'll probably be fine. But what we could do is crash the computer, or more likely crash Blender, right? Because now we are in what's referred to as exponential growth. In that, besides Lawson, who made 14 million cubes or whatever on Monday, usually you can't create that many things, quote unquote, by hand, just by copying and pasting, right? A lot of you are not going to sit here and hit copy paste 14 million times. You did it, yeah. But with the array modifier, it becomes much easier, right? So there's an important thing here to understand. The difference between instance and copy. So now we have two different things. Essentially, they're both clones, but one of them is fast. And so this one over here is the fast one. So if you, and the array modifier is fun. As soon as I show this to people, they're all, it's always like, oh, this is cool. I could do a bunch of cool things here. You should do a bunch of cool things here. But you need to just be more aware now that if you crank this way up, you want to be doing it in an efficient way. And so over here, this button becomes really important. And so the shorthand is that if you're going to make a lot of things, let's say big number equals uncheck this box, okay? Because if you realize instances, means that it's going to take the instances and convert them into actual copies. We want, if you're going to make a ton of them, you want them to stay instances because instances are fast. And so if I uncheck this here and here, I'll have more leeway for how large these copies can be. Right, and so now I've, really gone to town on the number of copies here. If I were to check these boxes, which I'm not going to do for the sake of our live stream, then at the very least, Blender would run slower. At the very worst, Blender would totally freeze up and you'd have to quit. And did it happen? Did someone freeze up Blender? Montana? If you have small numbers for the array, you're going to be fine because the computer will be able to handle it. But with large numbers, you want to make sure you uncheck realize instances because it will allow you to crank those to larger values. But this allows us to segue into a really an important next topic: saving your work. A couple things here. One, we want to do incremental saves. This is going to not put all of your eggs in one basket, meaning that if your Blender file gets corrupted and you keep hitting save all the time, you're out of luck because you've been saved into a corrupted file that you can't open. Number two is that you want to set the backup. And so let's do that. First of all, let's save this once. So I'll go save as and put this in the right folder. Here's me. I didn't save mine either. In here. And we'll call this week 1 example. And save that. And there we go. And so now if I look in this folder over here, there it is, week 1 example. Okay, now the first part of this, incremental saving. How do I save a new version? Let me change this like so. And then I'll come up here to File and I'll say, boom, save incremental. What does this do? It saves it as a new file and starts a count at the end. And so now the one with the highest number is the most recent one you've been working on. The way I keep track of this is that I just take my folders and organize them according to date modified. So whatever the most recent thing in the folder is at the top. Just makes it easy for me to know what the most recent thing is there. So this concept is called incremental saving, or you'll hear me refer to it as versioning. You create a new version of the thing. And again, this is part of your insurance policy against corrupted files, right? Now, if my most recent one gets corrupted, I can still go back one version. And will I have lost work? Yeah. Will I have lost all my work? No. Right? I would just have lost what happened in between those two versions. Does this make sense for everybody? Okay, good. The other insurance policy here is Blender's automatic saving. And so those settings are under Preferences and Save, and then here. So, autosave should already be on. Is it on when you open this window? Yeah, okay. And so Blender is going to automatically save your file again every 2 minutes. Up here, versions. How many versions does it keep? I put mine at 3. Okay. And so if I let this go for a little while, I should have talked long enough here. Let's see. We'll come back to it and we'll see that the autosave will also be accumulating in that folder. So we'll talk more about data and stuff later, but for right now, those will be 2 important strategies you can implement to just, obviously, 1, do great creative work. 2, save that work, right? If you lose all your work, that's not great. Does that make sense? Yeah, and that, especially the versioning concept, that should be something you do everywhere. When you're writing your paper for English class, for the love of God, don't just have one doc file that you keep saving. You want to have multiple versions of that, right? Because if it's totally possible for files to get corrupted, when it comes down to it, they are kind of fragile things. If something goes a little bit weird when it's being written to disk, things can get bad. And recovering that data is, sometimes impossible and often not easy. Okay, so versioning is just a new practice for your life of digital stewardship going forward. And then autosave is obviously something you want to keep doing. Let's see, did I autosave yet? It feels like 2 minutes have gone by. There it goes. Okay, and so Blender has auto-saved once. This is a Blender autosave, okay? But you say to me, it doesn't look like a Blender file, man. The reason it doesn't look like a Blender file is because the autosaves will have this number at the very end, okay? And because it's after the dot, the computer doesn't recognize the extension. The computer knows what a .blend file is. The computer doesn't know what a .blend1 file is. So in order to restore one of these autosaves, you need to click on it and then do 2 things. One is that there's most likely a file in the folder that has the same name, and that is a no-no, right? That's a Windows barrier. You can't have 2 files named the same thing in the same folder. That is not allowed. Like if you go to do it, Windows will say, no, can't do it. You need to rename this. And so the first thing is you need to rename the file. And then the second thing is you need to remove the suffix number, meaning the number after the file extension there, right? And so now if I click on this, if I click on it and I change it to like restore and then get rid of the 1, boom, and say yes, now it's now recognized as a Blender file that I can just open to see if the autosave caught whatever work I didn't to, or it didn't save before. So, does that make sense for everybody? Okay. So, two things. Again, but every program I can think of has these functionalities in it, incremental saving and auto saving, and you really want to be taking advantage of them to make sure you're not losing a bunch of work. Also, where on these computers, the computers here in the lab, should we save work? What's that? Demo storage, right? Everyone has that written down in your notes. Here, this is our wide open storage space. And so this is the D drive on these computers. Do not save our work in this class to your H drive space. It's going to fill up really quickly, and it's also going to be glitchy and slow because it's not a real drive. It's on it's in the cloud. And while that's great for your paper that you're writing when you're working on it here and then you need to go work in the student union or whatever, that's fine, right? But when you're doing all the 3D modeling stuff, it ends up just being way too slow, and it's also not very big for you guys. Okay, does that make sense for everybody? So data stewardship there. We'll talk about some other strategies later on, but that's a good way to get started. And then the array modifier, super fun, right? So here we have the grid. We could take this one step further and we could array the array of arrays. And so if we put one more on there like this, and then on the last one, I'm going to zero out the location there and then start to do this, right? Then uncheck this box, and then I could very quickly get to that 14 million. In fact, well, actually, this would be a good example to show this. Where is that? Here? Yeah, under viewport statistics. If I click this, there we go. This gives me this upper left-hand corner, and this is good in terms of these names and numbers should be meaningful to you now, right? How many objects are actually in the scene? And so that's surprising. I didn't think it would count the instances as objects, but it is. Yeah, it is. So anyways, like I could keep going until, yeah, if I do a little bit more here, there we go, and some here, and at the top. All right, so now I have about 200,000 spheres or cubes, and I can still move around in Blender, you know, pretty quick. This is crazy, right? Like, this has not been possible very easily, and so now the fact that we can do stuff like this is really, you know, pretty awesome. So the array modifier, doing grid-like objects, and then some other things to keep in mind here. Let's make this a little bit simpler. I'm going to get rid of that third one, and then come in here, and I'm going to finish my example that I got totally derailed from there. This, as this exists right now, is this procedural or editable? Procedural. Procedural. Ken is right. And I think a bunch of other people are about to say procedural as well, right? Yeah. Because the modifier instructions are the things that are generating the shape, right? The other word that you'll hear me occasionally use instead of procedural is generative, right? Similar, synonymous. Right, so how do I take that trip that we talked about earlier to go from procedural to editable? When we're talking about a modifier here, the thing that we need to do is apply, let's actually put that on the screen in a way that can be read, apply the modifier. And the way I usually do this is I select the object and right click and I use the convert to mesh command. And so that will make the modifiers go away, but then I'll have access to the points, edges, and polys. So we'll do that with this one right here. I will right click on this and say convert to mesh. Watch what happens. Boom. Okay, good. We all learned a bunch of things there. Let's step back. Everything got deleted. Why did everything get deleted? We had unclicked this to make sure that if we're going to make a ton of them, right? Let's put a number here. When do you want to uncheck this box? Let's say 50,000. Okay, we'll use that as our operational threshold for this week. Okay, so as long as you have less than 50,000 things in your arrays, then keep that box checked for precisely this reason. Because now, if I go ahead and right click and say convert to mesh, it works, right? It doesn't delete all my stuff. Because in order to have a truly gargantuan number of objects, they need to be instances. Instances are treated differently. Let's just leave it at that for now. Okay, but now, if I can grab this, I can go to tab and come in here. And let's say I want to move this. I had pretty much the shape I want, but I need to move this point. And turn off that snapping. And now I can do that. All right, can tab back out. And I can now grab individual points of all of these cubes to move as I want. Now it is editable because I converted to mesh. I have access to individual things. Is this helping? Another good example there. What was your name again? Your Anna. That's right. Yeah. The other, again, this is like the topology conversation. Which one's better, procedural or editable? It depends what you're doing, what stage of the creation process you're in. Any questions about this? Let's step back to where this is procedural. And I'm going to do that. So one other thing I wanted to point out, once we made it editable, now I can tap into edit mode. And then also notice what happened over here. Where are the modifiers? They're gone, right? Because essentially printed the modifiers into the mesh. This is a little bit like writing your paper for English class. When it's editable, it's in a doc format, right? When you go to print it or submit a digital print, you change it to what format? The publishing format for a document. PDF, right? You guys have heard PDFs, right? Like the Adobe PDF format. Because a PDF, is not directly editable, right? If you give someone a PDF, they can't start typing in it. It's like a digital printout of the thing, right? This is similar to that. Okay, let's look at some other. And so here, if I grab this object, one other good camera shortcut is the decimal point on the numpad. If you select an object and then press that, we zoom in on that object. So it's like a focus on that object. That one's useful. If you do any of the Ant-Man stuff, You can tell I've watched the Marvel movies at this point, right? So if I get out here, I'm in the universe, and I'm super huge, and I don't know what's happening. Again, select the object over here, come over here, press period, and zoom into it. The inverse is also true. You can zoom in to the point where you're like, now you're in the quantum realm, and you have no idea where you are, press period, zooms back out to some sort of reasonable level. So, not the period, it's the decimal point. The period would be the one over on the other keys. I talked about the numpad thing on Monday. Yes? For people on laptops? Okay, good. I actually do not know if you check that box whether that makes the period key function like the decimal point key. Someone report back about that next week. Regardless. Okay, great. A couple other things about the array modifier that are really fun here. It's a really great, this has recently been reconfigured, is that you don't just have lines, you could do a circle like this, in which case you see the procedural parameters change. And so the radius can be stretched out, and then you could have more or less of these. And then additionally, there's this, and we can unfold opt in and then start to have some real fun here with randomizing our array per rotation, per position, per scale. And we could combine the circular array perhaps with a linear array. And so the second one here will have in line, but I want them to be above. And so I'll say just do it on the Z. And so here I could start to stack this random array of stuff, but it's all still procedural. So if I come in and change any of the randomness for these, you see it populates up the stack, or down the stack in this case, right? So the modifiers, if you fold them up, the thing to write down here is order matters. Okay, it's math, and so order of operations is a thing, and the order that they're executed is top to bottom. So in this case, we're doing the circular array, then the linear array. If we were to switch these, yeah, that's a different result. And so then on the second array, if we were to randomize some of the scale on the second one here, you could, yeah, start to do this. And then let's also randomize the rotation on the Z. There we go, like that. And now that's interesting. And we could have more or less of those. Okay, one other thing to notice here. Now we've entered the world of randomization. It's important to realize one thing here. Randomization in the computer is not possible. The computer just fakes things being random, okay? In the way that a coin toss is random, like we don't know what's going to happen, the computer is a deterministic machine. There are no indeterminate components in a computer. So, how do we do random stuff? We just use a formula that's so, it's a deterministic inconsistent output. And by using that formula, we're able to create something that looks like randomness to us. We can't predict it, but it's not truly random. The point here being seed. Anytime you see the word seed, when it's related to randomness, it essentially allows you to change the random world or universe or multiverse which multiverse of randomness are you going to access? So, for instance, here in the second array, where I've randomized the height and scale or something, if I come down here to the very bottom where the seed is, the value of the number doesn't mean anything. All that matters is that it's different. And so watch what happens when I scrub this. I just get a different random result, right? So this allows me to bridge that gap a little bit between procedural and editable, right? Let's say that, I'm making this thing, but eventually, there's like some other thing I'm going to put over here. And so I want there to be a little bit of a dent. One way to do that would be to convert it all using that convert to mesh, and then just move these so there would be a little bit of a dent over there. Or I could sort of just search the multiverse for a version that has the shape I want. And because of this seed number, it makes it easy to just simply cycle through different random versions. This is not a Blender thing. This is a computer thing. You'll see this, now that you know this and you start paying attention to it, in any other computer program that has randomized stuff, almost always there's a parameter called seed that allows you to change the randomized stuff. The version of randomness that you're using. What is the other one here? Curve and then transform. Let's just keep with line and circle for now. That's good. And then if we wanted to take this one more level, right, we could, we like this thing, but we want it to be this, world of cubes here, or these like pillars, random pillars. And so I'm going to make one more array for, these start to get long, so I'm folding them up here. This one will become a circle as well, and then much bigger radius, like so, and then maybe a couple of them, and then put this down here like this, and then make a plane, and let's press S and scale that up like so. Maybe move this down a little bit. There we go. And then, there we go. I've kind of created this, Stonehenge-like kind of place. Now in here, just a few things about lights. This is a big thing, a big scene, right? And I want it to feel like I'm outside. And so two things to look at first. Directional light is going to be like you're outside. You only use one. Point light is going to be like a light bulb, more like you're inside. Up here under directional light, you only rotate. It's like the sun in the sky. You rotate it across the sky. A point light, rotating does nothing. You move the object, the G key. Let's see the difference. So, first of all, you're not going to see any of this when you are in solid mode. I'm going to save incremental because I've made a lot of changes. Then I'm going to switch to rendered view. So now Blender is actually taking into account the lights. I don't have any lights, so it's impossible to see much at all. Okay? And so I'm going to Shift A and create a light, and then, sorry, when I said directional light, sun. Okay? Directional light is like the sun. Every 3D program has these things, they just name them differently. And so the sun is the one we're talking about. So that makes it even easier. You want to be outside, make a sun. You want to be inside, make a light bulb or point light. And so here's the sun. There we go. The weird thing about the sun, by default, is going to be like directly overhead. And so now, if I press R and start rotating it, you can see it's like rotating the sun across the sky. The shadows change in a very similar way. Everybody see that happening? What happens here where it goes dark? Yeah, the sun has, we've rotated the light below our horizon. And so now we can't see it. And then dawn again. So not only can you dial this in, right? All I did was select the sun and press R. You could also animate such a thing to have light change over the course of the day. And you can see, now combined with the array and all these things, shadowing starts to give us a much more interesting dynamic scene here. So you can rotate in all of the directions here. Grab the sunlight, and down here, this is going to be the light settings. And so the biggest one here being the strength. How bright is this? And then if you want to tint the light, although from an aesthetic standpoint, a little bit goes a long way here. Like dragging these things over in this all looks pretty hokey. So a little bit of light tinting is okay here. We'll talk more about this at length later. Anyways, that's the sunlight. Let's look at a point light. Shift A, point, and there it is. The point light, unlike the sunlight, has a specific range here. And so you got to expand that out. And also the power is probably D less by default. In this case, I'm dragging it up and down and nothing's happening. The second one down here, exposure, is sort of a stronger one. But you can see how this starts to look like it doesn't work with this scene as well. Right? This scene, I think, is much more dramatic with the radiant or with the sunlight. But yeah, this assignment we're going to do this week is going to be about making the shapes and moving these shapes around. We can add some light, but don't get totally distracted by all the light stuff, right? That's part of the downside. It's a possible downside of using these kind of programs. Unity does a lot of crazy stuff, and so does Blender, right? And so your time would be best spent trying to focus on whatever it is we actually are talking about that week. It's very easy to get distracted by some other thing that we haven't really even discussed and have that totally derail you. Just be aware. That's a thing. Cool. Okay, so we use some modifiers to change some primitives. And yeah, this is the power of proceduralism, right? Is that this is all being constructed according to instructions. Let's say we build this thing for, this is like some sort of, monument in some sort of game that we're working on as the model designers. And they're like, we love it, but you need to bevel all the cubes. If this was editable, that would be a lot of clicking. Because it's procedural and it's all really just one cube with the arrays on it, we can come back to here, fold that one up, add the bevel modifier, and now all the cubes are beveled. because it beveled because it's in the stack. It's procedural. Just the tip of the iceberg in terms of what could be procedurally done here with instructions, right? This is technically an algorithm. We haven't written any code, but it's all there, just instructions stacked on top of instructions. Anybody watched any tutorials online about geometry nodes? Yeah, that's the next level of this, right? Once you've exhausted all of your modifier ideas and you want to take it to the next level, then diving into geometry nodes and doing all that, which we'll do some a little bit later, that sort of opens up the next level of possible procedural construction here with all of these things. Sound good? Okay, great. All right, so now we've got this. Let me think about it here. What do we do next? We've got this in here. Let's look at what we'll be doing this week. Okay, so there's a few things to understand artistically this week. There's two things to check out. There's a PDF here with a chapter from Scott McCloud's Understanding Comics. This is a book I'll reference probably several times throughout the course of the semester. Has anyone read this book, Understanding Comics by Scott McCloud? This is a comic book about understanding comic books, which is really a book about understanding visual communication. And so this is just one chapter from said book. So yeah, it's 24 pages of reading, but it's a comic book, right? Like it's pretty light here in terms of collegiate reading. The second thing I'll have to check out here is the case for abstraction. This is a really short video on, first of all, why doesn't he just play this stuff in class? This is the double-edged YouTube sword striking us down right now. Is that because I stream everything and it all gets recorded, I can't play any copyrighted music. If I play another video in the background, this all could cause the YouTube stream to come down, or not come down, but just they'll pull it off of YouTube. And so, yeah, I find this perpetually irritating, but it's, what YouTube giveth, YouTube taketh away. So we have that sort of situation here. Also, the fact that academic accounts still have ads is absolutely, like, this isn't the first time you'll hear me complain about that. Really, really irritating. Okay, so this is a really great series from PBS, short videos. It's just a couple minutes about different artistic concepts. And so the concept that you need to understand for this assignment is abstraction. And so we talked about two opposites earlier, procedural and editable, right? Those were two opposed ideas. The two opposing ideas here, which are artistic ideas, are abstraction and representation. Okay. Representation is what many people would classify as quote unquote regular art, right? So representational art looks like something. So a painting of a horse is representational art. You all have done this, presumably, right? You looked at something, you tried to draw or paint a picture of it, right? For a large swath of the population, that's what art is. looking at something and drawing it. It's a very narrow slice of what art can be. Abstraction is raw shape, color, form, not designed to look like a thing. Can you look at abstract things and find shapes in them? Yes, right? Everyone has done this. You've looked up at the clouds, which are abstract forms, and saw whatever you saw, right? What I'm asking you to do this week is make abstract stuff in Blender. Why am I asking you to do that? To just get used to working with the tool, moving the objects around, doing the things we did this week without getting sidetracked by trying to make it look like a horse, make it look like an anime, make it look like Sailor Moon or whatever it is, right? I just want you to get used to moving things around. And I also want you to become familiar with the idea of abstraction. Does this mean I need you to continue to make abstract art for the rest of your career? No, many of you will not want to do that, which is fine. I'm just asking you to do it this week. Everybody with me here, right? So the here, this is a really good, very, very, very short historical recap of the history of abstract art, in the different forms that takes. So abstract art, when it's raw form, can be super simple, like, where do the blocks go? So yeah, here, the Mondrian piece, right? It's just like some squares. Abstract. In this case, it's abstract and minimal. Both descriptors. Abstract art can also be super intricate and stochastic. Something like this, installation, right? That random checkbox should be, sounding some alarm bells in your mind, right? In terms of being able to create something that's complex and interesting, but not designed to look like whatever. We don't need to take the cubes. I'm not asking you to do this. I'm not asking you to take the cubes and arrange them into the form of a dog this week, right? Don't do it. Part of the reason I do this is so that everyone can get used to using the program. And then secondly, most of you have not been asked to do this. A lot of other art classes sideline abstraction. We're just going to explore it for a few days. That's it. Okay. But just like we said, because it's abstract, it just wasn't intended to look like a thing. And so I want you to make 2 scenes in Blender. Both of them will be abstract. One should represent the word chaos. The other one should represent the word order. Okay? Think about the tools that I've shown you over the past 2 classes. Some of them align much better with chaos. Others will be much more useful for representing order. Making sense? You seeing how it's all been building up to this? How I've set you up for this with the tools that I've shown you here, right? Grid snapping, chaos or order? Order, right? The random checkbox on the array, chaos or order? Chaos, right? Yeah. What can you use? Use your primitives, use the modifiers that we worked like. Can you explore some other stuff? Yeah, I would do that after you did something, right? Don't start off by trying to use some part of Blender, which we haven't talked about at all, right? Because that's a good way to like not have anything done later on. Make sense? Okay, so just one last thing here. Let me grab the Scott McCloud thing. Part of the Scott McCloud text that's super useful here here we go. Let's do this version. There we go. So, this is a really useful thought structure to have about meaning in art. So he refers to it as the picture plane. And so up here at the very top, we have abstraction, raw shapes. Down here, we have very, very simple representation, the smiley face. Over here, we have very, very detailed representation, a picture, a photograph of a face. And so a lot of times, in fact, pretty much all day today, I've been presenting things as dualities. This, and they're opposites, right? That's useful to an extent, but it doesn't really reflect reality in many instances. And so the reality of many situations is that things exist on continuums, where rather than opposites, they sort of transition from one thing to another. And that's what he's showing us here on the picture plane. So for instance, you could take a shape, a simple representational thing like a face, where these are all very, very simple primitives, but by sort of losing their location and meaning relative to each other, they become raw shapes, raw gesture, raw artistic gesture, abstract, right? So the top of the triangle is abstract. Both of these are representation, but they change in terms of complexity and detail. The point he makes here is that once you get past this, when it's not a drawing, then we get into written language, right? Where we're representing meaning not with any sort of visual art, but rather with words. It's kind of trails off onto its own separate thing at that point. We're not super concerned with that. But this is the much more detailed version where he uses some specific historical examples of simplistic representational meaning, simplistic abstraction. Working this way, we get to more complex abstraction, and then highly detailed realistic representation over there. So read the pages I asked you to read there. It's like 20 pages and it's a comic book. So, but really one of the, it's a really great text, used widely throughout programs, throughout, it's definitely a super important historical text at this point. Relatively recent though. Then if we look at this here, so this is all due Tuesday night at 8 o'clock. You have your 2 Blender files that you'll upload to Canvas, and then you'll record your presentation video using OBS, where you will show us both Blender files and like talk us through it. Keep it under, this is that deal I was talking about before. Is 2 minutes like really short? Yeah, it's pretty short. Do I want to see everybody's videos? Yes. So keep it down. Remember, you'll turn it in Tuesday night, Wednesday morning, or not morning, 4 o'clock when we're in here on Wednesday. We'll start class by watching everyone's videos. Okay? So I'll play them back here on screen. We'll get to see them. Hopefully the audio-visual sync issue is resolved by then, and we'll be able to give everybody some feedback on what they made. In addition to that, you can post some screenshots of your Blender render, just the Blender scene. So we'll get into rendering next week. How do I post this on Discord? Windows Shift S. Go ahead and take a screenshot of this and post that on Blender. That'll be perfectly fine this week. Sound good? Okay. Does the project make sense? Do you feel reasonably prepared for said project? I mean, you all need more time in the program, but you know, that's what this is for. And yeah, this is not, I mean, spend the kind of time you want. I'm not expecting you to spend all weekend crafting these scenes, okay? Spend, you know, half hour, 45 minutes on each, maybe, right? And try to represent chaos and order and use the tools that we talked about. Cool. Any questions from anyone on the live stream or here in person? Okay. Great. Is there anything else I wanted to say today? So, yeah, color, just real quickly. The idea is that we have a mesh in Blender, right? In our case, any of those primitives, and you can apply a material, and that's how we sort of get color on any of the objects. Just real simply, let's say this cube, we want to make this a color. Right here, this is the material tab. I'm going to click on that, and you need to say new. So that makes a new material slot here, and now I can control the color of the cube. Once you select a color, I would rename the material according to said color, and then you would be able to reuse that on other objects. In terms of like having different colors in the array, that's not on the table for this week. You can apply different materials to different objects. That's sort of where we're at with this right now. So if I make another sort of torus here, something like this, let's make it really big, like that, like that. Move it up here for our donut shrine. And now I can grab this, make another one here, and come up with a color like that. Other quick things here, roughness and shininess. So very, very shiny, very, very rough. And then whether you want it to look metallic or plastic. So left is plastic, right is metallic. That's the very beginning of this, right? Just if you want to have different colors, go ahead and work with that. There'll be weeks and weeks and weeks of talking about materials later on. Sound good? Okay. Yeah, so we won't go for the entire 2.5 hours absolutely every day. It just depends. But, you know, we'll definitely go for 2. Whether we get the last half hour in every time, you know, it depends. Sound good? Everyone feel like they got enough to do for next week? Okay. You've all taken the syllabus acknowledgement quiz. Remember what's due tomorrow? Yeah, the intro video, the whole technology orientation thing. And then this is going to be due Tuesday night. Everyone get the interlocking pattern now of assignments? Okay, great. Awesome, everybody. It's a good start to the semester. I'm really excited. You know, we got this awesome new space to work in. Coming up soon, we'll be looking at we'll be able to look at our Blender creations in virtual reality.
Thank you.
Yep, no problem. How are you doing? Did you make anything over the summer? What did you make? So what kind of Oh, okay. Is any of it going into games?
It's for mod for another game that already exists.
What game?
It was just Minecraft mod.
Oh, okay, cool.
But anyways, did you end up catching what happened on the Discord?
Yeah, I banned him this morning and got everything erased. Yeah. Yeah, that all happened like over the course of like just last night.
Yeah,
It was like
that was
asleep.
last night. And we just said a bunch of garbage and
Yeah.
dot content.
Yeah, no, I had a bunch of messages this morning, and then I banned. When you ban someone, it lets you erase everything they posted.
I
So I
don't
was able
know.
to
I
do it.
don't know if this other. I don't know if this other person.
Is there other stuff?
No, there's no other stuff per se, but there's this random I don't even know if they're. This random person burrito. I don't know, cause they were spamming at
Okay.
everyone when that happened. So my mind is saying that they're not actually enrolled at the school and they're just bringing attention to it just to cause
Okay. I'll ban
garbage.
Burrito.
Yeah,
Yeah, I don't think that's anyone.
yeah. I feel like they would change their name by now. But that was annoying.
Yeah, I mean that's the first time that's happened. We've had the Discord for like 4 years, so hopefully it doesn't become a regular occurrence.
I couldn't get anyone's attention and like messaging all the staff and nobody's awake. Obviously, nobody's gonna look at the Discord and what.
Yeah. I got to it when I woke up.
Yeah. All right. You know,
You too.